In this video, let's explore the architecture and design patterns behind large-scale video platforms. We will be taking a look at the systems that power popular video streaming services such as Netflix, YouTube, Twitch, and Prime Video. Let's start with a high-level overview. The video streaming system can be broken down into three major components: upload, processing, and delivery. First, during the upload phase, content is ingested and validated. Next, the processing phase involves encoding, transcoding, and optimizing the video. Finally, in the delivery phase, the video content is distributed via a content delivery network or CDN for streaming to users. Delving deeper, let's look at some of the key components in a video streaming architecture. We have an application programming interface or API, gateway, a media pipeline, a storage layer, and a content delivery network or CDN. The API gateway is responsible for request routing, authentication, and rate limiting. The media pipeline handles video encoding, thumbnail generation, and creating different quality variants of the video. The storage layer consists of a metadata database and a distributed file storage system. Lastly, the CDN provides global content distribution and edge caching. Let's examine the architecture of the upload service. Here's a simplified Python code snippet that illustrates the upload process. The upload service class contains a method called uploadVideo, which takes a file as input. First, the file is split into chunks for a chunked upload. Then each chunk is uploaded. Finally, the file is validated and processing is queued. Some key features of the upload service include chunked file uploads for large videos, resume capability for failed uploads, file validation and virus scanning, metadata extraction and storage, and queue-based processing trigger. Now let's explore the video processing pipeline. The pipeline consists of several steps, starting with transcoding, where the video format is converted and compressed. Next, thumbnails are generated for video previews. After that, multiple quality variants such as 480p, 720p, 1080p, and 4K are created. All of these variants are stored in a distributed file system. Finally, a notification is sent to indicate that processing is complete. Let's turn our attention to the database schema. The code snippet shows a sample table schema for videos in a database. The table includes fields such as ID, which is the primary key, title, description, user ID, duration, file size, status, and creation timestamp. Here are some key relationships within the database. Videos are associated with users, representing the creator. Videos also have a one-to-many relationship with comments. Additionally, videos are linked to views for analytics and files for quality variants. Let's dive into the Content Delivery Network or CDN architecture. At the center, there is an origin server, which serves as the master content repository. The origin server distributes content to various edge nodes located around the world, such as in the United States, East Coast, Europe, and Asia. These edge nodes cache the content closer to the users, thereby reducing latency, distributing load, and providing DDoS, or distributed denial of service protection. Next, let's discuss streaming protocols focusing on HLS, or hypertext live streaming. The code snippet shows how adaptive bitrate streaming works. The get quality function determines the video quality based on the available bandwidth. If the bandwidth is greater than 5000, the quality is set to 1080p. If it is greater than 2500, the quality is set to 720p. Otherwise, it defaults to 480p. Then the generate playlist function creates the HLS manifest. HLS offers features such as adaptive quality, chunk delivery, and seek optimization. Now let's cover scalability patterns. There are several different approaches to scaling a video streaming system. First, we have horizontal scaling, which involves load balancing across servers, adopting a microservices architecture, and using auto-scaling groups. Second, there is database sharding, which includes user-based partitioning, geographic distribution, and read replicas. Third, multi-layer caching employs Redis for metadata, a CDN for video content, and browser caching. Finally, asynchronous processing utilizes message queues, background workers, and an event-driven architecture. Finally, let's discuss system metrics and monitoring. Some key performance metrics include video upload success rate, average processing time, CDN cache hit ratio, stream start time, concurrent viewers, and storage efficiency. To monitor these metrics, a monitoring stack is required. Common tools include Prometheus for metrics collection, Grafana for visualization dashboards, the ELK stack for log aggregation, Jaeger for distributed tracing, PagerDuty for alert management, and New Relic for application performance monitoring or APM monitoring. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.